Yep, there's a lot to this video. Oh yeah, you too. I'm not gonna lie. Hey, I'm Dr. O, and welcome to my video, Dr. O's Rules of Significant Figures, Working Problems with Multiple Operations. In this video, we're going to take a look at how to do calculations when you have several different kinds of operations to perform, such as addition and multiplication, numbers with exponents and division, all rolled up into one single problem. We're going to review some rules on significant figures and then work some problems to get you on track to working problems just like the ones you see here on the screen. So, let's get started. Problems that have combinations of different math operations are going to be common in math classes, physics, chemistry, engineering classes. And it's also common that students don't remember the rules for dealing with significant figures in these calculations or never learned them in the first place. So, what skills do you need to possess to work problems with multiple operations? Well, you need to be able to determine significant figures of numbers. And if you need help in this area, I have a video. Dr. O's 3 easy rules for determining significant figures. You can find it on my channel. That's what the thumbnail looks like. You also need to know how to determine significant figures for the solutions of multiplication and division problems. And if you need help in this area, I have 2 videos for that. You also need to be able to determine significant figures for the solutions of addition and subtraction problems. As you guessed it, videos for that as well. And you need to know how to round. I don't have a video for that, but all that is covered in the other 5 that you see. So you need to know how to round numbers to reflect significant figures. So none of these skills by themselves is actually difficult, but I'm not going to lie to you. It just gets a bit tricky working problems with multiple operations. That's why the word easy is not in the title of this video or on any of the slides. So if your skills in any of these areas is a bit shaky, you will want to improve your skills because it'll make it so much simpler for you. So is there a roadmap to solving these types of calculations? Well, sort of, which is another way of saying no, not really. There's no single formula for every problem, but there are guidelines I can offer. One is to do the math following the order of operations. Now, the order of operations is a convention that dictates that certain math operations must occur before other math operations. And this order is outlined by the acronym PEMDAS. Now, I introduce it here, and I'll be going into more detail on this in just a few minutes. The other guideline is that you will be required to track the significant figures in any intermediate solutions while bringing all the digits of that intermediate solution forward to the next set of calculations. So what do I mean by intermediate solution? In problems with multiple operations, not all calculations occur at the same time. For example, you may be required to multiply 3 numbers and then add that solution, that intermediate solution, to a 4th number in order to get your final answer. Now the product of the multiplication, in this case the 8, is an intermediate solution. And for intermediate solutions, you need to know where the significant figures are, but still bring all of the digits forward to that next part of the calculation. It's important not to round your intermediate solutions at any point. You have to hang on to all of those digits. So you have to track significant figures and make sure you bring them all forward. Now the last guideline is that your final answer will be rounded based on the rules for determining significant figures for the last type of operation performed. If your final operation is multiplication or division, you're going to use the rules for multiplying and dividing when determining the significant figures of your final answer. If your last operation is addition or subtraction, you use those rules to determine the significant figures of your final answer. And if anything you just saw across the bottom of your screen looked foreign, I got a couple of videos you need to watch. So these are the 3 guidelines. Now let's take a look at PEMDAS. Here we have an equation, and we can see that there's an addition, a division sign, a multiplication, an exponent, and some parentheses. So in a problem like this, wherever do you start? Well, the order of operations dictates that the order to perform functions in math problems like this are to do whatever's in parentheses first. Second, you take care of exponent type things like numbers with exponents or numbers that were the result of exponents and that you're undoing, like, finding the square root of something. Next, that you perform any multiplication the problem may contain, as well as any division that may be in the problem. And coming into the home stretch, we finish up with addition and subtraction. When we take the first letter of each one of these operations, we get the acronym PEMDAS. So let's apply our rules to our equation. Now we do have a set of parentheses, so we would take care of whatever operations were in there first. In this case, it would be subtracting 30.14 from 35.17. Now, even though this operation is a subtraction, because it appears in those parentheses, we would do this operation first. Next, we would calculate 5.2 squared because the square is an exponent, and we do those types of operations second. Next would be multiplication and division, and we have some of those. But do we do multiplication before division, or does it matter? Well, if you think about it, multiplication and division are similar operations, with each being the reverse of the other. And here's our rule. You work multiplication and division in the order they appear in your equation, reading from left to right. Now, in our equation, division comes before multiplication, so that would be the order that we would perform those operations. So you would divide 13.01 by the square of 5.2, then multiply it by that intermediate solution that you got from your parentheses. This will become more clear when we actually work through a problem, and you can see how these steps go. The last operation that we have is our addition. And like multiplication and division, addition and subtraction are similar operations, with each being the reverse of the other. And the same rule applies here in that you work addition and subtraction in the order they appear in your equation, reading from left to right. Now that we have deciphered the meaning of PEMDAS, let's put our newfound knowledge to work. Alrighty, we have example number 1. Now, in these first few examples, we're going to be looking at just our operations, and we're not going to worry about significant figures. All right, so we look at our problem and we see we have a set of parentheses, a subtraction, a multiplication, and an addition. PEMDAS indicates that we perform whatever operation is inside those parentheses. So let's do that. 8 minus 4 is 4. Which I'm going to write in blue to indicate that it's an intermediate solution. And then I also bring forward the rest of the equation we've yet to work. Now at this point, we have a multiplication function and an addition function. The order of operations, PEMDAS, indicates that it would be the multiplication that gets done before the addition. So let's do that. So we're going to multiply 4 times 3, and this is 12. And I've put the 12 in blue to indicate that it's an intermediate solution. And of course, I bring forward the rest of the solution that we've yet to work. Now, our last operation is an addition. So we're going to add 12 and 1, and our final answer is 13. And we have successfully applied PEMDAS. Now, in example 2, again, we're looking at just our operations and not worrying about those significant figures. That's going to come later. Now, the operations that we have in this calculation include a couple of divisions, a set of parentheses, an addition, and a number with an exponent. PEMDAS indicates that we perform whatever operation is inside those parentheses, and we're going to do that first. So 9 divided by 3 is 3. And I'm going to rewrite the equation, putting our intermediate solution, 3, in blue. All right, now the operations we have to choose from now include a division, an addition, and a number with an exponent. Which one will be next? Well, it would be E. E is the second letter in PEMDAS. E stands for exponent, and we have one of those, so we are going to square the 2, which means that 2 times 2 is 4. And we're going to rewrite the equation, putting our 4 in blue because it's an intermediate solution, as well as the 3 that we brought forward. So we've so far worked through the E in our PEMDAS. All right, now we're left with a division and an addition to perform. What's going to be next? PEMDAS indicates that our next operation would be division, and that we are to divide 12 by 3. So let's do that. And our intermediate solution from that would be 4. So we have two intermediate solutions. Both of them are 4. Both of them are in blue. Our last operation is an addition, which means 4 plus 4, and our final answer is 8. Good job. This is our last example looking at just operations and not worrying about significant figures, so enjoy. Now, if we take a look at what we have here, we can see that we do have a parentheses, but we have multiple functions within that set of parentheses. We have an addition, an exponent, and a division. So how do you handle multiple operations within a parentheses? The same way you handle multiple operations in general. You follow the order of PEMDAS. So we're going to PEMDAS those parentheses. So within the parentheses and applying PEMDAS, the first order of operation we will address is the exponent. So let's take care of that. So we are supposed to cube the 2, which means that 2 cubed is 8. And we're going to rewrite the equation, and I'm going to put that 8 in blue so that we know that it's an intermediate solution. Now the next operation to perform would be the division, that division within the parentheses. And we're supposed to divide 8 by 2, and that's going to equal 4. And I'm going to rewrite the entire equation, putting that 4 in blue to note that it's an intermediate solution. So now at this point, we have an addition and a subtraction. Well, the addition is within the parentheses, which means that we're actually still working within parentheses. So we should actually do that first. So let's perform the addition next. So we're going to add 7 and 4, and that would be 11. And we bring the whole thing forward, and we have 11 minus 1. And our last operation is the subtraction. So we're going to subtract 1 from 11, and our final answer is 10. And once more, we have successfully applied PEMDAS. So here in example 4, we're going to be bringing it all together. We're going to be doing some PEMDAS and significant figures. So following PEMDAS, we're going to take care of whatever's in parentheses first, which means we're going to be adding 0.084 and 0.0055. And we're going to get 0.0895. Now this is an intermediate solution in this overall calculation, and the rules for significant figures requires that we track the significant figures of intermediate solutions while bringing all of the digits forward to the next portion of the calculation. So 0.0895 is an intermediate solution. How do we determine its significant figures? Well, we got the solution by performing an addition. What are the rules for determining significant figures when performing an addition or subtraction? Well, when performing addition or subtraction, we look to the least precise of the given values to determine the significant figures of our solution. And in this case, it would be the 0.084, which is precise to the 1,000th. So our answer from adding what was in the parentheses must be significant to the 1,000th. And that means our last significant digit in this intermediate solution is going to be the 9. Now we still need to hang on to that 5 that's to the right of the 9, but the last significant digit in our intermediate calculation is the 9, and we note that by putting a dot under it. You could put a line, but in this case I'm using a dot. Now we take this intermediate answer and we're going to perform our final operation, which is multiplication. And our product is going to be 0.092185. Now, this is our final answer, so how do we determine its significant figures? Well, our last operation was multiplication. So we're going to use the rules for determining significant figures in multiplication and division for our final answer. Now with those rules, we look to see which of the values we used to perform the multiplication has the fewest significant figures, and that will determine the number of significant figures of our answer. Now if we look to the value on the left, which is an intermediate solution, 0.0895, this has 3 digits, but only 2 are significant, and we know that by the dot that we placed underneath the 9. So this number will have two significant figures even though it has 3 digits. The second value, 1.03, has 3 significant figures, and 2 is less than 3, which means that our final answer will have 2 significant figures, which means our final answer is 0.092. Now, hopefully, this example gives you an understanding of the guidelines. And when following the guidelines, there are a few important things to remember. When you're working with problems that have multiple operations, the first thing to remember is that you never round intermediate solutions. You may have several intermediate solutions in the process of solving an equation, and rounding them even a little tiny bit can make your answer wrong. The second thing to remember is that you never round intermediate solutions, as this is going to throw some shade on your answer. And we don't want shade on our answer. And oh yeah, you never round intermediate solutions. So hopefully we're clear on that. For example 5, we're going to be tracking the intermediate solutions from several steps. And this will clearly demonstrate why you need to be solid with your significant figure skills. Now, following PEMDAS, we're going to take care of whatever is in those parentheses first. So we're going to add 0.075 and 0.0688, and we're going to get 0.1438. Now, this is an intermediate solution, which means that we have to track those significant digits while bringing all of the digits forward. Now, how are we going to determine the significant digits of this intermediate solution? Well, we got the solution by performing an addition. And what are the rules for determining significant figures when adding or subtracting? Well, adding or subtracting, we're going to look to the least precise of our given values to determine the significant figures of our intermediate solution. And in this case, it's going to be 0.075, which is precise to the 1,000th. So our intermediate solution must be significant to the 1,000th. And that means our last significant digit in our intermediate solution is going to be the 3. And we're going to mark that with a dot. Now, we still need to hang on to that 8 that's to the right of the 3, but the 3 is the last significant digit. Now let's take a look at what we do next. So we're going to take our intermediate answer and perform our next operation, which is actually going to be 2 operations. We have a division and we have a multiplication. And because these are separated by a plus sign, I can perform each of these and just bring them down. So I'm going to perform these at the same time, and through the magic of PowerPoint, there's my 2 intermediate solutions. 0.156,135 and 0.221. And like all intermediate solutions, we need to track the significant figures. Now, both of these were calculated using either a multiplication or a division. So we're going to be using those rules for significant figures to determine how many significant figures these intermediate solutions would have. Now, we got the solution of 0.156135 by dividing 0.1438 by 0.921. Now, 0.1438 has 4 digits, but only 3 are significant, and we know that by that little dot, that dot that's under the 3. So we can say that 1438, even though it has 4 digits, has only 3 of those digits being significant, so it has 3 significant digits. Now 0.921 also has 3 significant digits. And since both of our given values have 3 significant digits, the solution, or actually the quotient, which is 0.156135, must also have 3 significant figures. And we're going to note that by putting a dot on the 3rd significant digit. Now let's look at 0.221. We got this intermediate value by multiplying 0.34 by 0.65, and each of these values has 2 significant figures, which means that 0.221 must also have 2 significant figures, and we're going to note that by putting a dot under the 2nd significant figure, which is the 2. Now the last operation that we have to perform is this addition. And when we add 0.156135 and 0.221, we get 0.377135. Now this is our final answer, and we still need to determine the significant figures of this final answer. Now we arrived at this solution by adding. So to determine its significant figures, we use the rules for adding with significant figures, which means we look to the given values and see which one occupies the least precise place. And in this case, it would be 0.221. Its last significant digit occupies the 100th place, whereas 0.156135 has its last significant digits in the 1000th. So, because 0.221 has its last significant figure in the 100th place, our solution must also have its last significant digit in the 100th place. And we're going to put a green dot there so we can see that. All right, and now we're going to round this final answer to reflect our significant digits, and our final answer would be 0.38. This was the equation that was at the beginning of the video when I was introducing PEMDAS. And not actually doing that equation just kind of felt like unfinished business. So let's finish it now. Now, what's the first operation that we want to work? Oh, well, I would say that jumping P is telling us to do whatever's in the parentheses, and we have a set of parentheses right here. So let's do that math. We're going to subtract 30.14 from 35.17, and I'm going to rewrite the equation, and that intermediate solution is 5.03, and I'm going to put it in blue. And with all intermediate solutions, we have to track the significant digits, which means we have to see which operation we perform to get the solution, and then apply those rules of significant figures. Well, this was a subtraction, so we're going to look back to our given values to see which was least precise in order to determine the significant figures for our intermediate solution. Well, both of our given values in this case are precise to the 100th place, 2 decimal places to the right. So our solution in blue will be the same, and we're going to mark that with a dot underneath the 3. So what's the next operation? Oh, and we're getting a big hint from the peanut gallery with that hop and E, which means we have exponents. So we do have an exponent. It would be 5.2 squared. So we're going to square 5.2 and rewrite our equation, and we're going to put this new intermediate solution in blue. And as with all intermediate solutions, we need to track the significant figures. Now we got 27.04 by multiplying 5.2 by itself, which means that to determine the significant figures of 27.04, we need to determine how many significant figures our given value had. Well, 5.2 squared had 2 significant figures. 5.2 is 2 significant figures. And as it was the only value in our operation, 27.04 will also have 2 significant figures. So we're going to put a dot in the second digit of our 2 significant figures in that intermediate solution. All right, now if we look to the left once more, we can see what would be next would be multiplication and division. And remember, these are performed as they appear in the equation, reading from left to right. And if we look at our equation, we can see that we have both a division and a multiplication, but it is our division that's coming first. So let's work that. So we're going to divide 13.01 by 27.04, and we're going to rewrite that equation, putting that new intermediate solution in blue. And as with all intermediate solutions, we're going to have to determine its significant figures. So how do we get this new intermediate solution? We got it by dividing. So we're going to look to see how many significant figures each of the given values had. 13.01 has 4 significant figures, and 27.04 has 2. So even though we see 4 numbers present, only 2 are significant, and we know that because we previously made that decision, and we put a dot underneath the 7 to let ourselves know in the future that it was significant only to 2 digits. All right, so our two given values are we have 4 significant figures in one and 2 significant figures in the other, which means that our answer cannot have more significant figures than the given values with the fewest significant figures. So our solution in blue will have 2 significant figures as well, and we're going to put that dot underneath the 8 to indicate that that is our second significant figure. Now, as we move on, we're going to work the multiplication next. So we're going to multiply our two solutions in blue, and we're going to rewrite the equation with that new calculation performed. And now we have to determine its significant figures, and we're going to do that by looking at the given values. So if we look back to our two given values, we can see that 0.481139 has two significant figures, even though it has 6 numbers. Only 2 of them are going to be significant. So 0.481139 has 2 significant figures. And we see that 5.03 has 3 significant figures. Now, I'd like to point out that we have had to bring this particular value with its little dot forward 2 times. And this was the first solution that we solved for, but we're just now getting to involve it in our calculations. So this is why it's important to have a method to track this information, because you might be dragging these numbers around through several steps. So that's a bit about that. So we have a given value with 3 significant figures and one with 2 significant figures. Our intermediate solution from these two cannot be more than the fewest number of significant figures, which means that 2.420129 will be significant to 2 significant figures, and we're going to put that dot underneath the 4. And our last operation, it's going to be addition and subtraction, and we have one right here. All right, and if we do the math, we're going to add those two numbers together. We end up with 11.63013. And if we look back to our given values, we see that 9.21 has 2 decimal places, so it is precise to the 100th, and that 2.420129 with all of those extra digits is precise to the 10th. It has its last significant figure only 1 decimal place to the right, whereas 9.21 has its last significant figure 2 decimal places to the right, which means that 2.420129 is our least precise to the 10th, and our solution will also be precise to the 10th. So 11.63013 will get rounded, and our final answer will be 11.6. Whew. I don't know about you, but that felt like a lot of work. And I guess it really was. So when working problems with multiple operations, it's going to require that you know the order of operations, aka PEMDAS, that you know how to determine significant figures, that you know how to determine significant figures for solutions of multiplication and division, that you know how to determine significant figures for solutions of addition and subtraction, that you have a creative method for tracking this information while working your problem, and that you know how to round. If you know all of that, you're all set. And if you're not quite there, me and my videos are here to help you. I hope you found this video helpful. If you did, give it a thumbs up and a subscribe, and mark that notification bell to get a message when the latest video is uploaded. And if there's a topic you'd like me to do a video on, leave that in the comments below. And as always, do really well on your next exam. Thanks for watching.